Hello, 171 class. So in the last section, we talked about what is the difference quotient, but we also looked at these base functions, or what I call the base functions, that we're going to use to move around in the plane in this next section. Okay, so let's look at some examples of how we do these transformations of these functions. Alright, so the first type transformation we're going to talk about is the vertical shift. So a vertical shift happens when we add a constant to some base function, one of these functions on the last page, after that base function operation. So for instance, y equals x squared, or f of x equals x squared, was one of our base functions. So after the base function here is squaring, or the base function operation. So after I've squared, if I subtract 2, according to this up here, it takes the original graph and it moves it 2 units, c units in this case, downward. So subtracting 2 moves us down. So basically what's going to happen here is all the points that are on the graph, I'll plot them here in black, they're going to be moved down to these points that are in red. So it's going to take the graph y equals x squared and it's just going to move it down 2 units. Okay, y equals the absolute value of x plus 3. That's going to take the original graph, which is dashed here in black, and it's going to move it up 3. So where those dots are the points that have been moved up, and it's just moving the graph up 3 units. Okay, so adding a constant to one of the base functions moves it up, subtracting a constant moves it down by whatever the number is. Alright, now, what if we add to the input? Meaning, what if we add or subtract before we do that base function operation? So, again, the square root is a base function operation. There's the square root, but we added 2 before we took the square root, okay? Not after, like we did with these operations, but before. Well, what's going to happen here is if we add before we do whatever the function operation is, f acts on the input, it's going to move the graph to the left by c units. If we add or subtract before we do the base function operation, it's going to move the graph to the right. So this graph is going to move 2 units to the left. So all these points that I've got plotted here are points that are known, like 0, 0 is on the square root function. It moves over 2 to the left. 1, 1 moves 2 to the left. Right? 4, 2 moves 2 to the left. And this graph, this red graph here, moves, all of it moves 2 units to the left. Now you can see our base function and the new function. Okay? This one I didn't draw it too well. But anyway, what is this one going to do? Well, in the parentheses, it's like order of operations. We do parentheses first. The parentheses is before the cubing, which is, again, one of our base functions, x cubed. So we do the right 2 first, and then we do the up 2 second. So we're going to take our cubic function, we're going to move to the right 2, right, and then we're going to move up 2. Right, and we end up somewhere around there like that. Alright, so we take the original base function and we do more than one move this time, because we have something done in the parentheses which makes us move left or right. Then we have something out of the parentheses which makes us go up or down. Okay, in the parentheses or inside, there's no parentheses here, but think about how you would put it into the calculator. Okay, remember the calculator, absolute value, it gives the parentheses there. So with the parentheses, I'd have to put it in a parentheses here. So even though there's not a parentheses, it's inside the square root symbol, so we can think of it having a parentheses. Okay. Now you can always use your calculator to help you with these. So there's the absolute value function, and we can see it was, shifted. That's not what we had though. We had square root, my fault. The square root function x plus 2. I graph it there, you can see that it's shifted, and again it puts parentheses around it. And then this one here, parentheses x minus 2, that's moving it to the right 2. To the third power you can press math 3, that's cubing, and then plus 2. And then again, you can see what this thing should look like. It moves right to, up to, and there's our little cube root shape. Okay, if I go down below it and just do x cubed, graph that along with it, and there's that x cubed, and then it's moved right to and up to. Alright, let's look at another one. This is reflection over the x-axis. So if we take one of these base functions, here's the cube root function, right? And if we take that cube root function and put a negative sign out in front of it, right, the opposite of the original function, okay? Remember, f of x is y, so it's saying the new y coordinate is the opposite of the old y coordinate. So all these y coordinates that are on this graph are just being flipped over the x-axis. They're changing their sign from negative to positive or positive to negative. And what we end up with is a graph that we can flip over the x-axis. Right, and we end up with something that looks like that. Okay, now, what's going to happen with this graph, the second one, g? Well, we're taking the absolute value function, which is that v shape. We're moving to the right 4, because that comes first. That's the first thing that happens to this x. Plus 4, so that's going to move us, that's going to move us to the left 4, the opposites of the sign when you're in the parentheses. Left 4, then we're going to flip, because that's out in front after the absolute value, so we're going to flip over the x-axis, and then the plus 1 means we'll go up 1. So left 4, I'll put that vertex on negative 4, flip over the x-axis, alright, and then from there we move up 1, so take it and move that vertex 1 unit higher, so right about there. Alright, so left 4, flip over the x-axis and up 1. Alright, and then flipping over the y-axis happens if we negate the input, right, negate x before we do the base function operation. So before the square root, before the squaring, before the cube root, before the cubing, before the absolute value, if we negate the x value before all that, is the negative sign in front of the x is inside the symbol or inside of parentheses, then that's a flip over the y-axis. So the square root of x looks like this. That's the base function look. If we flip it over the y-axis, then all of those points have an opposite x value. Right? We negate x. That's what that means. So if I take this graph and I flip it over the y-axis, right, it ends up looking like this. So it was here, we flip it over the y-axis, and now it's here. Now, if you have other things happen, I know we said it's kind of like the order of operations is what dictates this, and if you go back and look at this one right here, it was the order of operations. What happens to x first? The plus 4. Alright, so that meant we moved to the left 4 first. And then what happened after that? The absolute value bars. Alright, that's the base function, so we don't factor that into the transformation because that is what gives it that V shape. But then the negation happened after that. That would be the next thing in order of operations, so that's why we flipped over the x-axis next before we added 1. Right, it would make a difference if we change the order. So the order of operations is kind of dictating things here. It is still here, but when the x is negative in these things, and it's inside the square root or inside of parentheses before your base operation, you always do that flipping over the y-axis at the end. Okay, so treat this as if it were positive x. Just kind of ignore that there's a negative sign there. If this were a positive x, what would I do? Plus 2 would move us to the left 2 places. Okay, so if I move this graph to the left 2 places, I'd be right there temporarily. And then, after I've moved to the left 2 places, then I flip over the y-axis, okay, which puts me right there. Okay, so that's where I end up. Now, let me just show you hypothetically, what if I didn't do it in that order? Right, what if I did it in the order of operations and flipped over the axis first, then moved to the left? What would that look like? Alright, we'll do this one in blue. So let's think that if I tried to do this with order of operations and I didn't do the flip over the y-axis at the end like we're supposed to, So again, this is what not to do. Don't do this. So here's the blue one. Alright, so right now it's just the square root of x. So let's flip it over the y-axis first, okay, and then move 2 to the left. If we did this in the order of operations, there's where we would end up. Right? There's, if I do this first, which that's the first thing that happens to the x, is that negative sign, that would flip it over the y-axis and put me over here, and then moving it to the left would put me here. Right? But this is what happens if we do 2 to the left first and then flip. We end up with this graph. Right? Which one is right? Remember, your calculator is just plotting points. It's just plugging in x values from left to right and plotting the y coordinate that goes with it. So if I did the square root of negative x plus 2 and close the parentheses, this is the one that it gives me. Notice it's the one that goes across the y-axis. Okay, so this blue one is actually wrong, but that's what you would get if you tried to do the order of operations as they happen to the x. Okay, so make sure that if there's a negative x, that you ignore the negative sign, treat it as if it were positive x. Do all the other transformations first, and then at the very end, the last operation you should do is flip over the y-axis. Alright, vertical stretches and shrinking. If you multiply a function after you've done the base function by some number, and that number is bigger than 1, right, it's going to stretch it vertically. Right, all the zeros are going to stay where they were. Right, but anything else gets stretched upward or stretched downward if it was already below the x-axis. If that number in front of the function that you're multiplying the function by is between 0 and 1, then it's going to compress or shrink the function vertically, meaning here's where it originally was, now we're lower or closer to the x-axis. Here's where we originally were before, the blue one, now we're further away from the x-axis. So we're stretching it away, we're shrinking it in the case where the constant you're multiplying by is between 0 and 1. Now remember, what about negative? It doesn't say anything about negative here. Remember, if you multiply by negative, that's when we flip over the x-axis. So it still does the same stuff. It still stretches it, but it also flips it over the axis. So it would be, down this way. If that's, see, we're a negative number with an absolute value bigger than 1. Alright, same thing horizontally, except it's the opposite direction. If c is bigger than 1, we're compressed in, we're shrinking, and we're closer to the y-axis. But if it's the number in front of x in the parentheses is between 0 and 1, then we stretch it out away from the y-axis. It becomes pulled further away. Alright, so let's look at a couple examples of those. So here is g of x equals 2 times f of x, and here is just plain old f of x. Now remember, what does this mean? This means, remember, f of x is the same as the y coordinate. So what we're saying here is, in our new graph, the y coordinate is double what it was in this old graph. So all we have to do is take these y coordinates here and double them. Well, if you double 0, you get 0. If you double negative 2, you get negative 4. Okay, that was taking place at negative 2. So there's negative 2. Now that's going to go down to negative 4. Okay, double 0 again, you get 0. So at 0, we're still at 0. Alright, when x was 2, double 2, you get 4. So I get 2, 4. Alright, and then double 0 again, I get 0. So 4, I'm back to 0. And so instead of this thing looking like this, where the lowest number is negative 2 and the highest number is positive 2, now our lowest number is negative 4. Our highest number is positive 4. Now, this is g of x equals f 2 times x. Okay, so we double the x first, then put it into the function. If you go back and look, if the number that you're multiplying by is bigger than 1, and it is, Okay, it is, and that number you're multiplying by is inside parentheses before you do whatever the function is, f. Then it compresses everything in. So what that basically means is all of these x coordinates, now I'm going to switch to blue, all of these x coordinates are going to be half of what they originally were. So instead of negative 4, 0, this is going to take place at negative 2, 0. Instead of negative 2, it's going to take place at negative 1, negative 2. Instead of 0, 0, it's going to take place at 0, 0, because half of 0 is still 0. So that point doesn't change. It didn't change before either. All right, negative 2, positive 2 will take place at 1, positive 2. All right, and then 4, 0 will take place at 2, 0. So this one gets compressed in vertically, horizontally, but vertically it's still the same height. Vertically it still goes from negative 2 to positive 2. Negative 2 to positive 2. Horizontally now, instead of negative 4 and positive 4, we're going from negative 2 to positive 2. So it was squeezed in, like we saw here. Okay? Oh, sorry, like we saw here. The blue line is the original graph. The red line is the new one. Okay? The y values, min and max, stay the same. It's just everything gets squeezed in towards the y-axis when that number in front of x is bigger than 1, okay, which was the case again here. Alright, so don't let the scaling fool you. This only went from negative 5 to 5. This went from negative 10 to 10. This still has the same height vertically. It's just squeezed in horizontally. Alright, what about the same graph? What about now? 1/2 f of x. Okay, again, that takes place after x is acting on f. So this is a y-coordinate, so half the y-coordinates. So take the y-coordinates and cut them in half. So now we're doing the y's again, 0, negative 2, 0, 2, 0. So 0 doesn't change, so that's negative 4, 0. Negative 2 will now be negative 2, negative 1. 0, 0 won't change. 2, 2 is going to be 2, 1. Alright, and 4, 0 is still going to be 4, 0. Alright, taking half of 0 still gives me 0. So this is what that graph would become. It get squeezed in or shrunk vertically. Alright, we compressed it vertically because that number in front of after we've done whatever f does as a function, we've taken half of that. Now, half of x, now we're going to take the x coordinates, and because that number in front of the x is less than 1, now this thing is going to be stretched out horizontally in this direction. Okay, if it happens after f is acting on x, it happens in the vertical direction. But if it happens before f acts on the input, it happens in the horizontal direction. And in this case, because it's less than 1, it goes out away. It's stretching it. So negative 4 is going to now, this negative 4, 0 is now going to be at negative 8, 0. Now think about it. What is 1/2 of negative 8? Half of negative 8 is negative 4. And the y-coordinate for negative 4 was 0, so negative 8, 0. Negative 2, 2. The negative 2 is going to take place at negative 4, negative 2. Alright, half of negative 4 is negative 2. And then the y-coordinate, when the x-coordinate is negative 2, is negative 2 also. So it's stretching us out this way. We have to ask ourselves, basically what we're doing is 1/2 x equals the old x-coordinate. The old x-coordinate was negative 2. So multiply both sides by 2, and you get 2 times 1/2 is just 1, or just x. 2 times negative 2 is negative 4. So 1/2 x equals the old x-coordinate the new x-coordinate is -4, and that's what I'm doing here. Okay? So let's move to the next one. All right, 0, 0 is not going to go anywhere. I'm going to just fill that one in. But now, 2 is the x-coordinate. So 1/2 x is equal to 2. Okay, so what's the new x-coordinate? Well, again, multiply both sides by 2. 2 times 1/2 is 1x. 2 times 2 is 4. So x equals 4 is the new x-coordinate that's going to be paired with this 2. So 4, 2. All right, and then finally, the last one. Okay, +4 is the old x-coordinate. G gives us our new function. The new function takes the old function, and we have half the x-coordinate. So half the x-coordinate was 4. Double both sides, I get the new x-coordinate is going to be 8. That's paired with that last 0. Okay, so that's where it's coming from. That's the math you're doing to get this. Okay, here you're just taking half the y-coordinates. That means 1/2. Remember, f of x means y. But here, it's kind of like you're having to solve for the new x-coordinates to know where these points are going to go. Okay, so just remember, half multiplied by the x or whatever the input is before the function name. That's going to go out, away from the y-axis. If it's bigger than 1 before the function name, that's going to go in towards the y-axis. Alright, if it is bigger than 1 and it happens after the function, that's going to go away from the x-axis. And if it's less than 1 and it happens after the function, that's going to go in towards the x-axis. Alright, so remember, out of the parentheses is up and down, vertical. Inside the parentheses is left and right, horizontal. Alright, let's do one last one. So same function, f of x plus 2, then doubled, then -1. We've got to do the order of operations on this. So plus 2, that's going to be 2 to the left. Okay, double, right, when we double after the f, that's the y-coordinates. So double the y's, right, that we're going to stretch away from the x-axis. And then the -1 is down 1. Alright, this is, we don't even know what this function is. So this is completely generic, and you just have to know what happens to these functions, how the shifting works. Alright, x plus 2. That's going to go 2 to the left. So every single one of these points on this thing are going to move 2 to the left. Alright, here's what that original function will look like if we put it on this scale. Again, -5 to 5, -10 to 10. So it's going to look already smaller, but it's actually the same function, just on a new scale. So if we went 2 to the left, I'm going to pick this thing up, move it 2 places to the left. Alright, so instead of starting at -4, it's starting at -6. Instead of ending at 4, it's ending at 2. Okay, so there it is, moved 2 to the left. Now double the y values. That means we're going to stretch it vertically. Alright, so I've doubled the y's. Remember, this was -4, -2. Now it's -4, -4. This was 0, 2. Now it's 0, 4. Okay, so I've moved them to the left. I've doubled the y's. All the y coordinates that were 0 are still 0. And now I move it down 1. So I'm going to pick this thing up and move everything down 1 unit from where it was. Alright, and there's where we end up with. So there's this thing. We moved it to the left. Okay, so it went off center to -2, being the center. And then we doubled the y's, which stretched it up and down vertically. And then we moved everything down 1. So that center that went to -2 is now down at -2, -1 right there. Okay. So there, anyway, there's a generic function, which means a function we don't even know what the original base function was. We just know what it looked like. And we can still shift it and move it around if we understand what all these different things do. So remember, in the parentheses, that movement is horizontal, left and right. If there's numbers in front of x, again, we're compressing in or stretching out horizontally. If the numbers are outside of the f, outside of the function name, and that's happened vertically, if it's bigger than 1, it's stretching, smaller than 1, it's shrinking. And then if we add or subtract after the parentheses and after the function, then that's a shift up or down. Okay, so just do your order of operations and move the function around the way it's supposed to be moved. Alright, now I want to show you what happens when you do your homework in this section, when you do these different types of problems. If you, I'm going to blow this up a little bit. If you see this has the parentheses x minus 6 cubed plus 4. So this is a cubic as our base function. Remember, a cubic looks like this. So as soon as I click it, what it's going to say, click on the cloud departure curves. I'm going to click here, okay, and then as soon as I do it, it gives me this thing to ask, all right, how are you going to stretch it, and all the different things. So this one goes to the right 6 units, right? Right 6 units. I don't need to stretch it vertically. There's no numbers being multiplied, so I don't need to do this top. The shift, I need to go to the right 6. So if I start dragging this, oops, that's vertical. My fault. I need to go to the right 6. So there it went to the right 6, and then it needs to go up 4. Alright, so there's where it would end up. I don't need to reflect anything, okay, but there's where we end up with this thing. So save and then have it check your answer. Okay, but that's how that tool works there. You can't just plot it in there where you want to. You've got to use the tool to move it around. Alright, and then some that you have to match the graph. Don't forget, if you're having trouble with this in 1.6, don't forget you have a calculator that can help you with this. So if I'm stuck and I can't remember how this thing flips and shifts and does all that stuff, I can just type it in. So remember, h of x, g of x, f of x, r of x, all those things just mean y. So h of x equals is the same thing as y equals. So I just click the y equals button. It's a negative, so I'll click this for negatives. This is subtraction. Cube root, I can find that under math. Option 4, there's cube root of x minus 2. Alright, close my parentheses, hit graph. And so there is my graph of my cube root function. Okay, it moves it to the right 2, and then it flips it over the x-axis. So it's normally like this, at that kind of S shape through the origin. I flip it over the axis, and now it's like this, and then I go to the right 2, and I end up right here. Alright, and then you just match it up. Which one does that look like? It looks like, of all these choices, it looks like this one. Okay, so don't forget you have your calculator to help you with this section as well. Okay, now there are going to be those like this where the calculator can help you. You'd still have to know how to use the tool though to get it to look like what your calculator screen looks like.